Hello class 9. Let's solve exercise 7.3 from your Ncert book. Question number 1. Triangle ABC and triangle DBC are two isosceles triangles on the same base BC, and vertices A and D are on the same side of BC. So let's check the diagram. In triangle ABC, we have the triangle ABC here, this large one, and DBC is right here. Okay, so these two triangles are isosceles. That means that AB is equals to AC and DB is equals to DC. Now, if AD is extended to intersect BC at P, that means this line AD is extended further to point P, so that point P lies on BC. That means AP intersects BC at P. Now we have to show that ABD is congruent to ACD. So from the given diagram, what we can see is ABD is this particular triangle at the top and ACD is this one right here. Now in these two triangles, we already have understood that as because ABC is an isosceles triangle, then AB equals to AC. Again, triangle DBC is also isosceles. That means these two sides are also equal. So we can get these two sides are equal, these two sides are equal, and right here AD is a common side. So can't we use the SSS congruence rule here? So we'll clearly write down ABD. In triangle ABD and ACD, AB is equals to AC, AD is a common side, and BD equals to CD. Hence, using the SSS congruence rule, ABD is congruent to ACD. Again, please keep a note on the name of the second triangle. It should completely depend on the name of the first one. Now, by CPCT, what we can say is these two angles are also equal. These two triangles are congruent, so therefore the corner angles here are also equal. Therefore, BAD is equals to triangle CAD. We are marking it as equation 1 because we need it later. So for question number 2, they have said we have to prove that ABP is congruent to ACP. So ABP is this entire triangle and ACP is this entire triangle. Okay, this one and this one. Now we have to prove that they are congruent. Now to prove they are congruent, we already know AB equals to AC. Now AP is a common side. If we can prove that BP equals to CP or these two angles are equal, then we can see that they are congruent, right? So see, from the previous congruency, we can already say that BAD equals to CAD, right? By CPCT, BAD right here is equals to CAD. Since it is already there, we can use it. So we have AB equals to AC, AD is a common side, and the angle between them are also equal. Therefore, in triangle ABP and ACP, AB equals to AC, angle BAP equals to CAP by this, and AP equals to PA, that is the common side. Therefore, by SAS, side angle side congruence rule, triangle ABP is congruent to triangle ACP. Part 3 says that we have to prove that AP bisects angle A as well as angle D. Now, in this triangle, we have already proved using the congruency of triangle BAD and CAD that these two angles, angle BAD is equal to CAD. Since these two angles are equal, that means this line BD or BP, AP or AD is actually bisecting it. Hence, we have proved that angle A is bisected by AP. Now it's turn for angle D. So for angle D, we can choose these two triangles. The reason is, to prove that angle D is bisected by AP, we have to show that BDP is equal to CDP. And to prove that these two angles are equal, we can take these two small triangles and prove that they are congruent. If they are congruent, then we can say that by CPCT, these two angles will be equal and hence TP or AP will bisect it. So, since angle BAP equals to CAP by equation 1. Therefore, we can say that AP is the bisector of angle A. Again, since ABP is congruent to ACP, therefore we can say that BP is equal to CP. Let's mark it as equation 2. We will require it while proving the congruency of these two triangles. So in triangle BDP and CDP, we already know that BD equals to CD as it is given. Then BP is a common side, and by equation 2, BP equals to CP. So the three sides are correspondingly equal to the other three sides of the other triangle. Therefore, we can say that by SSS congruence rule, triangle BDP is congruent to triangle CDP. Therefore, by CPCT we can say that angle BDP is equal to angle CDP, and hence we can say that BP is bisected or AP is bisecting angle BDC. Hence, we can say as a whole that AP is bisecting angle A and AP is also bisecting angle D. The fourth part says that AP is the perpendicular bisector of BC. We have to prove that AP is the perpendicular bisector of BC. That is, not only it is perpendicular but also it is bisecting. We have already proven the bisecting part by equation 2. Here we know that BP equals to CP. That means that AP is bisecting BC. But we have to prove that AP is also perpendicular to BC. That means these two angles are 90 degrees. Since BC is a straight line, we can say that these two are linear pair of angles. Since these two are linear pair of angles, the sum of these two angles will be 180. So, by congruency we can say that APB is equals to APC because triangle APB is congruent to ACB. Therefore, these two angles are also equal. So, these are equal and BP is equals to CP. We are getting from this triangle. Okay. Now, since they are linear pair of angles, we can say that the sum of those two angles equals to 180 degree. Now, we already have proved that these two angles are equal as these two big triangles are congruent to each other. Therefore, these two angles are equal and their sum is 180. So, therefore, we can say each of them are 90 by calculation. So, here we are getting the condition that AP is perpendicular because APC or BPC are 90. Therefore, AP is perpendicular to BC and also BP equals to CP. Therefore, AP is perpendicular and also bisector of BC. Question number 2. AD is the altitude of an isosceles triangle ABC in which AB equals to AC. Show that AD bisects BC. So let us take the diagram. Let ABC be a triangle where AB equals to AC. That is, it is isosceles in nature. Now, AD is a perpendicular on BC. As a result, angle ADC is equal to angle ADB. That is equal to 90 degree. Both are 90 degree. Okay. Now, to prove that this AD is bisecting BC, we have to prove that BD equals to CD. So, in the triangle, we can say in triangle ABD and ACD, we already have AB equals to AC. Then these two angles are 90 degree and AD is a common side. So, what we can see here is we have right angle and opposite to it is the hypotenuse. So, the hypotenuse are also equal and any other side, so AD here is equal. So, we can use the right angle, hypotenuse and any side congruency rule, that is RHS congruency rule. Therefore, triangle ABD is congruent to triangle ACD. So, by CPCT we can say as they are congruent, then BD will be equals to CD. Now, since BD equals to CD, therefore D must be the midpoint for the line BC, and hence we can say that AD is bisecting side BC. For the second part, we have to show that AD bisects angle A. So AD is bisecting angle A. That is what we have to show. To prove that, we must show that angle BAD is equal to angle CAD. Now, to do so, we should have proven that these two triangles are congruent. We already did it. Therefore, since triangle ABD is congruent to angle ACD, we can say by CPCT, angle BAD equals to CAD. So, as these two angles are equal, therefore we can say AD is bisecting the total angle A. Question number 3. Two sides AB and BC and median AM of one triangle ABC are respectively equal to sides PQ and QR and median PN of triangle PQR. Let's understand the figure a bit. So we have a triangle ABC and PQR. Here they are saying that the side AB is equal to PQ. So this side AB is equal to PQ. Then BC is equal to QR and the median AM is equal in length with PN. So since AM and PN are median, that means that they are bisecting the base BC and QR into two equal halves. That is, M is the midpoint of BC and N is the midpoint of QR. We will utilize this information. So we have to prove that ABM is congruent to PQN. But before that, let us note down the relationship between the two triangles. So in triangle ABC, we have AM as the median. Since AM is the median, we can clearly write that BM is half of BC because M is the midpoint of BC. We can mark it as equation 1. Again, we can take triangle PQR and here PN is the median. Therefore, we can say QM is half of QR and mark it as equation 2. Now, it is already given that BC is equals to QR. Since the side BC equals to QR, we can put the values from equation 1 and 2 and we are getting half of BC equals to half of QR. As because half of BC equals to half of QR, we can say that BM is equals to QN using equation 1 and 2. Hence, from these things we are getting the relation that BM is equals to QN. To prove ABM is congruent to triangle PQN, we need a congruency rule. What we can see here is AB equals to PQ, AM is equals to PN. These things are already given and we have just proved in equation 3 that BM equals to QN. So we can see all three sides are correspondingly equal to each other. So in this triangle, we can write down that in triangle ABM and PQN, AB equals to PQ, AM equals to PN and BM equals to QN by 3. Therefore, by SSS congruence rule, ABM is congruent to PQN. The second question has asked us to show that triangle ABC is congruent to PQR. This entire triangle is to be congruent. So from here what we can say is that as ABM, the small triangles, are congruent to each other, we can say this angle B is equal to angle Q by CPCT. Right? Angle B is equals to angle Q. Now, in triangle ABC and PQR, we know AB equals to PQ, BC is equals to QR as given, and these two angles, this one and this one here, are equal by equation 4. Therefore, we can say by side, angle, side, they are congruent. Hence, in triangle ABC and PQR, angle B equals to Q, AB equals to PQ, and BC equals to QR. Hence, by SAS congruence rule, triangle ABC is congruent to triangle PQR. Question number 4. BE and CF are two equal altitudes of a triangle ABC. Using RHS congruence rule, prove that the triangle ABC is isosceles. Let's see the diagram. ABC is a triangle here, and CF and BE are altitudes, that is, they are perpendiculars to the side AC and AB. Not only that, BE and CF are also equal in length. So since they have asked us to focus on the RHS congruence rule, we have to focus on the right angle triangles here. So the right angle triangles here are BEC and CFB. Clearly, we can also say that we have AFC and AEB as the right angles, but we have other relations here as well. So let's see, we are choosing these two for the sum. Now, since BE is perpendicular to AC, therefore, we can say that it is right angle. In the right angle triangle BEC and CF, we can see that BE is equal to CF, BC is a common side, and these two angles are equal. So what we can see is we have 90 degree for triangle BEC. Opposite to it, we have hypotenuse which are equal in both the triangles, and any other side, for this case BE, is equal to CF. So we can say that by right angle, hypotenuse and any one side, we can say that they are congruent using the RHS rule. So triangle BEC is congruent to triangle CFB. Since they are congruent, therefore we can say by CBCT, angle BCE is equals to angle CBF. BEC is right, BCE is here, and CBF is right over here, that is angle B and angle C. Since these two are equal, therefore their opposite sides are also equal. For angle B, the opposite side is AC, and for angle C, the opposite side is AB. And hence we can say that AB equals to AC using this theorem, where opposite sides of equal angles are equal. Hence, since two sides AB and AC are equal for triangle ABC, therefore ABC is an isosceles triangle. For question number 5, ABC is an isosceles triangle with AB equals to AC. Draw AP perpendicular to BC to show that angle B is equal to angle C. So if you take a triangle ABC, then it is given that AB will be equal to AC, and we have to draw AP which is perpendicular to BC. Now we have to show that angle B will be equals to angle C. So since AP is perpendicular here, therefore angle APB and angle APC both are 90 degree. In triangle ABP and ACP, we have angle ABP is equal to APC, these two are 90. Then AB is equals to AC, which is already given, and here AP is a common side. So what we can see is we have right angles, opposite to it is the hypotenuse, those are also equal, and any other side here AP is equal. Therefore by RHS congruence rule, triangle ABP is congruent to triangle ACP, and hence we can write down by CPCT this angles, angle B and angle C are also equal. I hope the video was helpful to you. Thank you for watching it. Take care. Bye bye.